This training explores Abaqus cold forming analysis in detail. It includes 3 workshops that cover different steps in the cold forming process: coiling and uncoiling, press breaking, and rolling. For validation, we have compared the results for the numerical simulation of cold forming with a reference solution for each workshop. Have you ever heard of cold forming process? It refers to the reshaping of metals into desired forms at room temperature. It suits well for parts requiring high precision and a good surface finish. While cold forming offers many advantages, it is important to consider the potential for residual stresses within the material. The residual stresses in cold-formed components can influence their behavior, potentially affecting the quality of the final product. Experimentally measuring these stresses can be challenging. Numerical simulations offer a solution for cold-forming residual stress analysis. Among the available numerical methods, Abaqus cold forming simulation has gained significant attention from researchers and practitioners. The residual stresses resulting from cold forming exhibit a nonlinear variation across the thickness of the section. They significantly impact the mechanical behavior of structural members made from cold formed sections. These residual stresses originate from 2 main sources: 1, the coiling, uncoiling, flattening, and 2, the cold forming process itself. However, laboratory assessments of residual stresses across the plate thickness in cold-formed sections are challenging and sometimes impossible. Numerical cold-forming simulation addresses the limitations of cold-forming residual stress analysis. However, such simulations may present some challenges. We have discussed these challenges below. In the process of coiling-uncoiling or cold forming, the metal sheet frequently undergoes plastic deformations. Therefore, it is necessary to account for the nonlinear behavior of the material for cold-forming residual stress analysis. Additionally, during the cold-forming process, the metal interacts with rollers and punches. Hence, it is important to consider these complex interactions in numerical cold-forming simulation. Another challenge lies in applying boundary conditions to the specimen in a realistic manner for cold-forming simulation. All of these factors contribute to the complexity of numerical cold-forming simulation. However, Abaqus CAE has simplified all these challenges for us. It offers a straightforward yet precise framework for cold-forming residual stress analysis. We can utilize Abaqus for simulating the coiling, uncoiling, and flattening process, as well as press breaking or rolling, without significant limitations. If you have questions about Abaqus cold forming analysis, don't worry. We have prepared step-by-step guides through workshops for you.